Buongiorno a tutti, sono Valeria Cei,
Good morning, everyone. My name is Valeria Che. So I'm speaking from the Info Packaging production. So welcome to our meeting
ai nuovi materiali ecocompatibili per il
dedicated
futuro.
to the new eco-compatible
Abbiamo
materials.
avuto il piacere di seguire
We had the pleasure
la partenza di questa prima edizione di
to
Biopolymer
see the
a
kickoff of
Fiera,
this first open edition together with
e abbiamo
Verona Fiere.
partecipato alla comunicazione di questo
Our journalist
evento.
is,
Abbiamo
of course, dedicated to comment
organizzare
the event. We wanted to organize this convention, inviting both Parma's University and CICAP, both to talk about the packaging role, also for the bio-food supply chain. And I'm going to leave the floor to the professor who is going to be in charge of explaining what's happening. So good morning, everyone. Welcome, Valeria. Thank you for giving us the possibility to participate to this very interesting event. My name is Roberto Montanari. I'm responsible and the director of the CICAP Center, which aims at supporting companies for developing and strengthening the technological base that is becoming increasingly important, especially in the last years, both for the mission of our university, especially when it comes to supporting the territory with all the skills that help it. So the CIPAC Center is one of the most important one. It is the most mature center in our network. It is an interdepartmental center which was born in 2009. And as I said before, it is designed for supporting company packaging-wise, and especially it is concentrated on the territory's needs. Why that? I also wrote it down and stressed it because it is a super interesting aspect. When students ask me, well, Professor Mr. Montanari, what is the product that, in your opinion, will be more and more developed globally? And the packaging is the answer. The packaging gets everywhere. Every day, on a daily basis, we deal with packaging. It seems strange, but a product that it might be simple, but actually it is very complex. It is one of the most spread products worldwide. That's why we really have to invest as for research and continuous improvement from companies, but also from research centers. And out of this philosophy, we wanted as university to support companies through a body, through an entity that is the CIPAC, namely an interdepartment center connecting more departments and units, but we're going to see later on. In any case, it does focus on two specific branches. So the first one is strictly linked to packaging, therefore the material itself. And it is quite obvious to understand that this is the focus of the attention the moment we talk about packaging, namely the materials with specific functionalities that are more and more complex, servicing clients and companies. But what's the aim? Well, the aim is protection. We have to protect the environment and against the environment. Then in addition to that, we also have an issue of communication. So packaging actually encompasses many, many aspects. But it was born specifically for these two main reasons. Then another key aspect, at times overlooked, are the needs linked to the plans dedicated to packaging. So, for example, research and development and all the technology that supports the aspect. It is not only directed to the material, the chemistry of the many materials that we are about to use, but also the real plants, the real technology dealing with the plants, backing and supporting the creation of our assembled parts, because that's what we call it. It is conjunctions, it is a cluster. And then, of course, the packaging, which is covering the material. This comes also from the territory's needs. Parma, as it is the capital of the food valley in Italy, and Emilia-Romagna as a region in general, we're talking about the northeast, acts as the main center in the agro-food sector, and it is also very rich of companies transforming agri-food product, but not only. As a matter of fact, they also create the plants, the equipment, and all the tech tools that can foster this production. So these skills in the mechanical field, we talk about machines, as I said, are well recognized all over the world. And these companies today are an interesting conjunction points for the export of machines and plants. So stemming from the need of the territory, because we want to transform some specific materials, we decided to focus on this coverage for the international market. So these are the two big answers that CHIPAC wants to give to the territory. That is the answer given in terms of packaging and in terms of plants. So the CHIPAC, as I said, it is an interdepartmental center. But what's the meaning of this? Well, it means that the answer we want to provide is not a one-way and one-sector answer. It is a multi-side answer. This is a very broad topic. It involves chemistry, the chemistry of packaging, but also the product packaging, and all the fractions that might be between the product and the material that is actually going to protect and cover the product. Today with us, and I thank in advance my colleague, because he's going to provide a brilliant further explanation. And he will expand on the chemical of the product in the container. There's another colleague of mine, Professor Femilan, and he will analyze in depth all the new aspects of the materials covering food. This is like when we talk about the science of food, we are a little bit university style talking, because what we do is touching on a context that sees the agri-food as one of the main pillars of many economies. That's why in our tiny context, food must be the gold medalist. And of course, packaging follows suit. But packaging means a variety of things, a variety of elements. Let's not forget the Department of Economics and Business, because this is supporting research and development. Research shall be based on a rational analysis of costs and benefits in such a way that we can keep being interested and interesting on the market. And then there's the engineering of all the story. I'm an engineer myself, and so of course I'm particularly concerned about the environmental impact that packaging might develop territory-wise, nation-wise, and globally. So Professor Vignani We'll talk further about this aspect. And nowadays, this point is of much talk because we really want to give kind of a voice to the objects. And so to create and to use the smart labels, some elements that allow objects, the objects surrounding us, to communicate one with the other, but especially with us. And so on this side, I will hand over then to my colleague, who will also conclude the GPAC presentation. Unfortunately, we do not have enough time to explain you everything, but my colleague, the professor I mentioned before, will expand on this last topic. Engineering means also logistics, supply chain. It means also the relationship that we have between the supply chain and then the shelf life of the product, which of course is born by the product itself. And then it is again attached to the supply chain. So it is something quite complicated, I must say. And it cannot be one way, but necessarily must be supported by a multi-channel and multidisciplinary program. So from this point, we do really have the choice, and we've been efficacious on this side to create a think tank that is absolutely multidisciplinary in such a way that we support the territory on the CHICAP topic. So this is a cluster of services. We will not be able to touch on them, or not on every single one. So I'm not going to read them all. It's just an idea. It's just a slide that wants to give you an overall idea. And we really try to help supporting the companies on this big topic. So here there's a summary of the main aspects. So as for the packaging, the environmental impact is key. So if I wanted to, with some words, just to put it up, these four elements, because the objective is to service everyone, all of them, who wants to start a collaboration to improve, because there's much to do, and also a very tiny improvement can help spreading this material worldwide. But in any case, it will greatly impact the territory. So the next interventions, and I thank again the speakers who supported me, Professor Daniel Milanese, Professor Mucchino, Professor Vignali, Volpi, who will touch on the four topics that I mentioned before. So I don't want to steal time, precious time, from my colleague, and so I leave the floor to Professor Daniel Milanese, who will touch on the new materials for packaging. So thank you very much. So, good morning, everyone. Thank you, Roberto. Thank you very much for inviting me to take part in this event. So I'm going to talk about some activities on new materials for packaging, especially looking at the technology and the engineering of the materials. So we are about to talk about innovative materials on the basis of some existing molecules. I work for the University of Parma in the Department of Material Engineering, and I been working in GPAC for long now. What do we deal with? Well, we deal with biodegradable polymer materials. And touching on today's topic, what do we mean when we talk about new packaging materials? We talk about two categories specifically. Glass packaging, that is a bit particular because it is a glass biodegradable glass packaging, and then there's a filler biopolymers, which is the second category, of course. And I will talk mainly about the idea and the processes. As for the first aspect, biodegradable packaging, we know that glass is part of that category of materials that is inside the category. Sorry, but we cannot see your presentation, Mrs. Valentina says. So he shared his presentation, but unfortunately we cannot see it.
Proviamo un attimo. Ovviamente poi ricordiamo che tutti i materiali, le presentazioni dei...
So of course we remind you that all the materials they will get to us.
Benissimo, perfetto, grazie. Buon proseguimento.
Okay, we can continue. Okay, thank you. So, biodegradable materials, and we do have biodegradable glass. We know that glass has a specific characteristics because, as we know, glass is perfect due to its characteristics to be, of course, used but also recycled. So what we would like to introduce, it is a challenge with the characteristics of glass plus another. So the fact that it is biodegradable, which is not only biodegradable, but it can also be. It is interesting because it can also be become a compost. So there's a phosphate base, and we want to transfer it to packaging. So we presented a project, and we hope that we can have again this presentation. So as for the glass packaging, of course, it is a biodegradable material, but we know that there are many and high costs. So, of course, there's a strong impact. And also the diffusion of glass implies reaching a temperature that are up to 1,400, 1,500 degrees. And I'm talking, of course, about silica-based materials. Then, as I said, silica is another example. So in any case, we do have costs that can be quite high. And we really have to deal with the situation. So the idea is to develop a glass that is completely dissolvable within the environment, trying to cut the energy costs, therefore the environmental costs of cleaning and collecting, and also to try and reduce as much as possible wastes. For providing a new image, a new company image. Why glass? Well, we know that glass it is, as for packaging, quality container. So I don't know if you can see that at the supermarket there are not homogenized food for babies or jam that is in plastic container. We do have glass container for these products. Yet, what we want is a biodegradable material. So what's the solution? The solution is trying to have kind of a container-like packaging, therefore biodegradable. So the glass is the central part of the frame, therefore it does have a structural form. So we do have a transparent, rigid, inorganic, biodegradable material. But at the side, so I'm talking about the external side of the container, we have kind of a barrier. It is an inner barrier, which is needed in case the fluid or the material which gets into contact with the wall can or could interact with glass. Of course, this is not mandatory, it might not happen, but if it does happen, we need to protect it. But there's also an external layer that protects glass against external agents or environmental agent aggressions. And so we do not want to act inversely against the food that is contained in the glass. Now, the second sector, packaging based on biopolymers. So the idea is to carry out biodegradable packaging within a biodegradable polymer matrix characterized, as we know, by lightness, plasticity, but can also be completely renewable, and use some natural particle strengthening. So this is needed for increasing the mechanical resistance, but also for being environmental sustainable, and also for changing the structural and functional properties. So this can also help in reducing the cost. And as I said before, it is extremely sustainable because it might resort to some wastes. So these two components form a biodegradable packaging, a fully biodegradable packaging. So how can we prepare it? And I'm just giving you some examples as for the facilities. So we do combine polymer A plus polymer B because, of course, we need to have composites, copolymers, or in any case, combination of polymers. That is, we need A plus B. And B can be a micro or nano filler. So this corresponds to a blending and compounding, which is combined inside an extrusion system with two screws, allowing for obtaining the material as if it was a very long thread. So it is not specifically homogenized, or better said, it is homogenized inside some long threads. So this thread can be used as it is. It can be used as a strengthening material, as a support material, or what we can do, we can also perform a 3D printing with some little like test shape, or we can have it in sort of pellet, which allows again to have this final small material that is then easily used. So we can use both methods, and in any case, thanks to forming project, we can use it no matter what. So film blowing again can be also the final technique for getting to the packaging. And so this is the contact should you need further information. Thank you. So thank you very much. And I will now leave the floor to another colleague that will deal with a portion that has become more and more interesting. That is the migration analysis. Because we can have a service on the territory to all those who might be interested in understanding what is the interaction between the product and the material which sustain the packaging. So now I'm going to hand over to my colleague who is an extreme expert, and he's going to explain us how this company of his is providing this service more and more required by companies. Thank you very much for your attention.
Ringrazio ovviamente per il gentile invito Okay, so now we're going to talk about our group as it's composed by different experts. We work in a team, and I'm here to represent my colleagues as well. So, why are chemical analysis are so important? Because of course, by interacting with the content, it is an integral part of the process for which we may have some release. We may all know that we may all remember that in the food field we do not want to have some any type of contamination, but this is something that is extremely important also for other fields, other sectors, for example cosmetics, where problems may be even more serious because the substances that the packaging may contain um, are more serious, can be more risky. Also, in the pharmaceutical field, we were talking about glass before. And in this field, some special glasses were developed and contain very particular components. I'm here to talk about not talk about what we do in the laboratory, well, not in this moment, but I would like to draw your attention to a service that CPAC can provide. In a moment in which I'll have the packaging, I will be able to go back and trace back the behavior and the toxicity of a migrant component in order to have an interaction, in order to see if there is an interaction between these substances and to see if I can use this substance for the packaging. Because I would like to remind you that packaging is not only what we see. For example, one foil that we usually see for in supermarket, it's composed by different parts and with different functions that act as a barrier. And of course, we should also consider that there are so many other substances that may risk to migrate. So it is important to study at the initial level the behavior of these components, as first of all we can safeguard health, but we can also define migration limits, so the maximum quantity of substance used and the conditions of use. For example, this can only be done at the initial phase. Skipping now to what's the part that is more analytical, CPAC Center is able to carry out all the analyses that are usually carried out in a normal laboratory. And today we're focusing on food because it's the one that is more important to us. But we could apply such analysis for all categories. Migrations are not only the ones that we think about, so from the packaging to food, but can also be vice versa. So we could have the composition of the packaging or a problem about that. Of course, it is all done based on reference standards. We have some conditions that we should follow because it's unthinkable to produce specific food that goes specifically in contact with a specific packaging. So in this case, we would use the substances based on the reference standard. By considering migration, which we can determine the quantity of a substance migrated, the most interesting thing is studying the specific migration, and even here we have a reference standards, and we act based on that. But we could also have other substances that can migrate even though not regulated, and so we're not able to define them and to see if there may be problems, especially in the shelf life of products. Just a recap. We could carry different analyses. Here you can see an overview of one of our laboratories. So, as well as sensory analyses and screening analysis. Something that is a novelty in our field that is related to the evaluation of the chemical composition of the substance. We all see in advertisements, we can all see the composition of some of the substances. Well, what we're able to do is to carry out analyses about these substances, and especially as related to metals, we're able to evaluate what are the variations based on the technological advance. You know that frozen food are like very common today, but for them we use very different processes, and from here there may arise some variations in the food properties. So we apply all the common techniques that are used in a laboratory to carry out analysis on these substances. Just to give you an example, and this is a very typical problem. It has nothing to do with migrations, but it's a problem that we had. So it was this bad smell that consumers noticed in bottled water, especially in sparkling water. And this was a study, was a pretty long study that we carried out to understand what was the component in the packaging that produced this bad smell. This is just to give you an example of what CHIPEC does, because it's not only a laboratory carrying out analysis, but it's also a laboratory that can help you in all stages of the development of your packaging. In conclusion, this is our main project from this department from MUR, where researchers are part of the CHIPEC. What they gave to us was a tool, a very technological tool this mass spectrometer that is the unique here in Italy, and we're the reference center for spectrometry, mass spectrometry with high resolution. Thank you very much for your attention. Thank you, Claudio. Thank you for this presentation because it's very important for us, both in scientific and technological terms, because it's a tool that can support so many companies that need to be sure about the kind of material they use in order to ensure a quality service to their clients. The mission of our center is to support them and make them focus on their core business, but also auxiliary operations or activities that can be they can pass on to third parties. So the focus should be on the core business of the company. So the outsourcing of these activities is more and more based on is very important nowadays. Why? Because we have systems that are very complex and they make it difficult to have a general overview of all the activities carried out. So I think that interdepartmental center could be a very precious resource, and it will also be for our next topic, because it's not very common to have all the knowledge my colleague has in relation to environmental impact. Here's my colleague, an engineer that has been focusing his skills on environmental impact. This topic is very contemporary. The fact of having packaging at the center of some polemics, some discussions that, however, should be clarified if we want to have a rational approach to have a cost-benefit evaluation assessment, always focusing on the service to the client and the final goal that the product should have. I would like to leave the floor to Professor Vignali that will speak about the environmental impact assessment. Can you hear me? As Professor Montanari was saying, I'm here today to explain something about the environmental impact of packaging. It's something that should be assessed through concrete tools and not theories. To do that, we should first consider some data on packaging in Italy. We know that the food sector is the leading one as related to packaging, especially to primary packaging. But also the secondary packaging has some significant impacts. So in the assessment that we're going to illustrate, we should consider all the environmental profiles of the products, and we should assess all the stages, so primary, secondary packaging, and so on. As you can see here, the turnover of packaging was more than 34 billion euros. Is is sustainable. So the use of packaging is sustainable. How can we quantify that? We can say that sustainability is based on three pillars. From an environmental point of view, we can, but it's something that companies know that there should be an economic sustainability, because we also need corporate social responsibility in the process in evaluating which material could be the best one. To do that, so to carry out an environmental impact assessment, we have to consider the life cycle of our product. Also, when we talk about packaging, the life cycle is not only about packaging, but of the packaged product. Let's not forget that a high-performing packaging can improve the life of the product that packaged they need. A very important aspect is food waste. How is it possible to quantify the environmental impact of our packaging? We can do it by the analysis of the life cycle, and it's something that we have been doing in this field. CPAC has focused on production and distribution of the product in order to provide some technical support to our clients in order to assess what to include, what to exclude, how to assess the material and the production phase. The life cycle assessment starts from the analysis of the material, the treatments used for the packaging, the distribution and the requirements for the distribution, and for example, assessing differences between frozen food or shelf table food. Another evaluation is the impact on the table, so the impact of packaging, and the type of life end, for example, wasting and potentials, current potentials, the ones defined by some specific bodies for packaging. So we should evaluate, assess the recycling possibility of some materials compared to what is the current possibility that sometimes is very limited. To do so, we have been relying on specific softwares for several years based on the reference ISO standards. Together with companies contacting us, we also use some very strict policies as the ones related to the EPD sector, so the environmental product certification, that can support companies in case they want to certify their products. What are the advantages of the LCA? First of all, the first phase is defining a goal. Sometimes we want to assess all the stages of our packaged product, but sometimes it is also important to compare different processes that can apply just for one part, one stage of the packaging. So it is important to compare them based on the same systems, for example, a gate-to-gate system in which we want to compare what the companies do in the production field compared to the production system supplied by other companies. And in this case, we have limited analysis, so from gate to gate. And so it's not cradle to gate, it's a different approach for this analysis. Based on the units and the functions, so our reference for the analysis, we have an inventory analysis that is carried out to gather all the information for the environmental impact assessment. What we do is we introduce some components to the process, and we evaluate the impact on the soil and the impact of the use of water and other substances that we may use for the transformation. All these inputs are included in the stage together with some outputs. So we evaluate the impact on the soil, in the air, and the complexity of the system. This is done also considering production waste during the production process. Based on these, we build up the whole process, always taking into account the limitations of the systems that we decided to use and of the functional units. Because sometimes we have some criteria that we must follow and some guidelines coming from the European Union. We also rely on data banks and some softwares that we use internally, for example, Invent or other data banks on agri-food. So all the banks that are available. We insert primary, secondary data coming from data banks, and once completing the inventory, we assess the impact. This can be done through different indicators. Sometimes we hear about greenhouse effect that is expressed in kilograms of hydrocarbon produced. But as for the food industry, the indicators that are used are also related to water consumption. And so the use of water that can be included in a water food item, but we have different impacts to which correspond different calculations. We not only have to assess the use of water, but also what we release in the atmosphere. We have other items like the use of renewable sources, and also considering the impact of biodegradable sources. We also have to consider this another parameter that is related to the use of the soil. So for harvesting, that may have a higher impact if compared to other solutions. So we talk about global warming potential and emissions of carbon dioxide, use of water, or waste of water. And from that, there we analyze the results. Of course, we could have different results based on the indicators because the substances that we have in the inventory contribute in a different way to the effect that we want to analyze. As you can see here, we have carbon dioxide and other items that contribute to different indicators. They are classified based on their characteristics. Each substance contributes in a different way to the same environmental product. So based on global warming protection, so considering this parameter, this one that is very used nowadays, when 1 kilogram of carbon dioxide has a very strong impact, as a certain impact, but if we consider other materials, of course, based on the methods applied for the impact, the results may be different. And this can be chosen by the final assessment that we want to have. If we have assessments that must follow an European Union procedure, we would apply some other methods that will implement other standards. And this is important to say, as we all know. People should know the type of assessment used, the type of criteria used in order to have an objective result. As for packaging, this leads to a certain result. From a research point of view, in the evaluations of the packaged product, we also have the impact of waste. So waste and losses. Based on different types of food, we have different shares of waste that are based on different uses. As for the household waste, 31% is related to packaging, because this is a percentage that could be reduced. In evaluation of packaging, most of the time we should consider the shelf life of the product. Another very important aspect is that the impact of food sometimes is higher than the packaging impact. Packaging can avoid food waste and lead to a better result in terms of global impact on our packaged product. You can find some certifications on EPD website showing out this topic of waste is very important. Considering other countries, for example, North America, the waste component is very high because the losses part is reduced. So from here, we can understand how the packaging assessment and waste assessment is very significant. As I was saying before, we should consider packaging based also on products such as cereals, vegetables. Environmental impact And considering the environmental impact also related to the production of the product, what we see is that meat, vegetable, and cereals, some very high percentages, and also the water wasted is very high. As Professor Montanari was saying at the beginning, the part related to packaging evaluation should be included in a food waste evaluation. Also because the use of food waste is pretty complex, because once we produce some waste, the benefits that we have are very limited. What can we do about packaging materials?
We can try and improve the sector as we're already doing in Italy, because we're absolutely avant-garde in Italy as for recycling. Well, because we know the world production is quite high. So over the years, in Italy, we see that the collection of plastic packaging is increasing during the last years, making the product recyclable. So I need to get to conclusions because we're running out of time, Giuseppe, so sorry about that. So this is just to say that recycling increases, and so we have to look for recyclable packaging because we have to try and use at our best what we collect. And so collecting everything at the level of the plastic, this system allows us to use at its best the plastic packaging, and PET is of course the most promising one. So some other biomaterials can be considered, but as you can see from the percentages, we will, in any case, try to improve also this recycling process. I'm sorry that I've been speeding up fast, especially until the end, but there's a lot that Parma University did in terms of research. But of course, you will reach out to that through links or through some, of course, researchers that will be willing to talk to you about it in the future. So thanks a lot for the time given me. Okay, thank you very much, Professor Vignali. As you could see, the topic is of paramount importance and fascinating. And so I thank Professor Vignali for your passion, the passion that you have at the service of everybody, because that's the main concept. So for those who wish to reach out to him personally, we're going to provide his contact. There are many aspects that pose not really threats or in any case burdens. I would like to see it as a key element, and many companies have been using it for long. But this is just to try and be more and more competitive. We're a little bit behind schedule, and so we still have another topic, which is beautiful, I must say. Why so? Well, because it is very innovative. In fact, in the last period, communication has become, alongside with information, a key aspect, and it is the core of many processes. In addition, we really want to develop business on top of it. So innovation means making people talk about us. So we really create new tools and elements, being the voice to those things that do not have a voice. And so thank you very much, Professor Volpi, for being with us today. He's an expert in RFID technologies, identification technologies, supporting also this key topic that is packaging. Not only from a visual point of view, but for long, packaging is always being a tool of communication, but starting from today can also become a new tool of communication. And we can really help and aid more modern technologies. So packaging is really becoming a key resource. And now I hand over to Professor Volpi, who will present the smart label. So how can we make products talk and packaging talk? Thank you very much, Roberto. Welcome, everybody. My name is Andrea Volpi. I'm, of course, a colleague of all the professors that have so far spoken because we work in the same center. So what I would like to focus on in my speech are those functions, those functionalities that are becoming increasingly important when it comes to packaging. So packaging that have specific functions, especially depending on the purpose of their design. We need to proportion the product, we need to contain it, we need to protect it. So today, packaging shall be a smart type of packaging. And when I say smart, I mean using the product in a simple way, so allowing also the users to use it in a simple way, and having functionalities plus this easiness of use. Then we talked about active packaging because they do react with the product. And now we are peering into one of the last characteristics of the packaging. Intelligent packaging, as a matter of fact, is what we see. So, but what do we mean when we talk about intelligent packages? Well, as a matter of fact, they can really provide information about the product they protect, and also information about the state of the product, starting from producer until the final user. So why are they intelligent? Well, we all are experienced in buying on Amazon, so we click on the e-commerce and we trace the pack because we really want the box, the pack, to be right on the threshold of our house. But how can we trace it? Well, we can trace it by using or trying to get to the automatic technology that allow data for being acquired and collected also by the final user, the final consumer. So this is a need that we all share because it is quite easy to view the product also when the courier is transporting it, and the courier shall send information about the product. So, for example, whatever the time, because they can give it to you at any time, but I want to be sure if I can get it at 3 p.m., if I want to get it at 11 a.m. So our life rhythms do want us to be able to trace what's coming to us. So all this information is available if the packaging is somehow equipped with technology that allow us to acquire data automatically. Because it is thanks to this automatic way of acquisition that we can also match our crazy at times rhythms of life. And so we cannot think of inserting data manually. This is absolutely impossible. But not only for tracing the delivery, but for the delivery itself, because if we think about products that should be maintained at a controlled temperature during the delivery, this is an important indicator, and it is also a mandatory point to try and preserve it rightly. But then an additional valuable services. Sometimes I talk about packaging and product as if they were the same thing, and in certain cases they are. Because the way some products start from the producer and they end up to the consumer, the packaging is cannot be considered but a single unit with the product. Now, it is absolutely unlikely to buy freestanding products or free products in general. So giving functionalities to the packaging is just an added value. And then we also have as I said, added value services that today are of paramount importance. For example, the possibility of recording the product, therefore to obtain the guarantee for some discounts connected to the product. And here we've got marketing offices that are absolutely great in working this way. But there are like thousands of use cases so that the client can smartly interact with the product and the packaging. This is allowed the moment we can apply automatic technologies. So packaging with smart technologies. I want to make my packaging talk. How is that possible? Well, I can apply some labels. I can use it during the supply chain, and so they can give indications of the pattern as for temperature, for example, as for processing. So when we apply the labels on the product, we also try to provide all the specific chemical information, the specific temperature information, as I said before. And then we have the RFID technology. I am absolutely sure that we are quite familiar with Decathlon, with Zara, with these big companies. So on the product, we have the RFID labels that, thanks to reading a pen, they can automatically detect the product once we get to the counter. So we basically place the product inside a sort of intelligent box, and the labels reveal the state of it. So we can apply these labels to the product, but also to the packaging. When the product is, when we talk about clothing, we don't have a packaging, but also for the packaging there are no problems, and we can apply it at an industrial level. Sometimes we want to apply labels at semi-finished products. So there are different actors actually forming part of this big cluster. And then we've got the data logger, which is an intelligent device that resorts to a memory, and it can implement very varied technical logic. So we can have simple data loggers that reveal the time, humidity, temperature that it's mandatory to have collected on a specific computer program, until some complex devices able to know the product they are applied to, and they can also forecast the shelf life of the product. They also can predict some other aspects of preservability according to the environment that is surrounding the product. And it is important under the light of the supply chain, because I'm not saying that if a product shall have always the same temperature and for 2 minutes the temperature is out of the range, the product is at risk. I'm not saying that. Yet, in any case, we really have to try and control some specific categories. And so here it comes the sensor at our help, also with some algorithms that can help the shelf life. So the sensor will be able to give us also an estimate of, in terms of shelf life. So maybe I should use a product a couple of days before, just in reason of the journey of traceability that the product went through. And so I can also have some data about the quantification of the violation that the product unfortunately was submitted to. So the sensors that we have seen are somehow applied and integrated in the packaging. But as for the good sake of the information getting to the client, we need to create a solution that implies not only the sensor on the packaging, but also a structure in such a way that the information gets from the sensor to the cloud. And for us, we know that today it's quite easy and quite common. So we can have a real-time updated piece of information. And by definition, the sensor is local. So it is a local device, absolutely friend with the product. And today we have at our use range of technologies that are more consolidated and we know them because we use them on a daily basis. So, for example, a wireless network or Bluetooth. Of course, the Bluetooth is kind of a bridging technology, so it connects a sensor to a device that then somehow is connected to the product, the packaging, or the net. Or we can also have the smartphone or cell phone technology. So to date, we have some new developments for sharing information, especially when it comes to net. Therefore, LP1 or high P1, so low power net or high power net. And they try to emulate or substitute wireless, but they really pay attention to the low consumption and watching also the wallet that sometimes is costly. And so we have the low range LoRa technology. And recently, starting from September, they have officially been recognized, and the functioning bands and frequencies have been allocated to these technologies. Also in Italy, it means that they are very pervasive, and they will be a reference point from now on. So these nets can make these sensors pick. Maybe they go through gateways, but in any case, they are supported by a well-defined network structure with low costs. And so I maintain the sensor connected. We try to have different networks. So, for example, like the cell phone network. The cell phone net, and it is not very costly because it is like a bunch of dollars per year, so it's not that expensive. But they sometimes have kind of a strong limitation on data, like some dozens of kilobytes per day. But especially in Europe, they are receiving a very capillary coverage. So it's better, it's getting better over time. So we can get the information that the product gives to the sensor, and we can share it on the cloud or on the net. And it is useless to list now all the specific use cases that we can have. So if I'm talking about a specific chain, I will probably create a dashboard that can give value to the property of the product itself. For example, maintaining the right temperature. If I'm a courier, I will share the traceability data of the package that I'm about to send. And if I'm thinking about applications for the end user, I might create a dashboard that somehow can connect the information with added value to some services that I can provide to the final user. Clearly, what we can do is carry out some feasibility studies, some tests on the devices, detect better solutions, considering the specific context. And we know that technology can help us a lot, but we really have to fish into the bucket and try to get out the best one for us. And of course, depends also on the specific requirements that we have to apply to the specific use case. Therefore, for example, the supply chain or distribution chain I'm referring to. We can carry out experiments, tests with all the devices at our hands, with the aim of really crafting a handmade and complete, tailored solution based on the traceability of data. So with this, I'm over with my intervention, and of course, I leave the floor to my colleagues should we have questions. Thank you very much, Andrea. Thank you very much, Professor Volpi. So what you see now in the slide, it is kind of a sum up of all the interventions and the personal contacts of my colleagues, including myself. Should you need and want to reach out to us for additional information, for curiosities, we will be available. So I hope I haven't bored you too much during the presentation. Of course, I mean, I've enjoyed a lot my colleagues' presentation, so I want to thank them dearly, and the organization and all the people who have attended this chat. And thank you for contacting our center. And now I am handing over to the organizer of the conference for our next intervention. Of course, we're available for answering the question. Decide how you would prefer to reach out to us and our center. Thank you again. Thank you very much, Professor Montanari. We will give your contacts. So now we are going back to Professor Corradini, who are integrating element of a GPAC, but they're also leading the mastering packaging of the University of Parma. We are going to talk about degradable packaging with them. So I leave you the floor, Professor Corradini. Thank you very much. And of course, I hope a debate might come out from this presentation, because the topics are very important. I hope you can see my presentation. It's going to be visible briefly. And is it visible? Maybe let's wait for a couple of seconds and see if it comes out. Maybe we can try again and see if you wish to load it again. It's funny because I'm about to use the one that I used during the test, so it should work. Can you see my screen now?
Noi vediamo soltanto il riquadro con la sua immagine, non la vedono ancora neanche dalla regia, quindi è possibile che forse vada...
It seems that there's a little bit of delay because we cannot see the slides of the professor.
Ok, mi avvisano che dovrebbe arrivare a qualche istante, quindi secondo me possiamo partire.
It should get to technicians shortly, because otherwise we run too late. Okay, that's good, that's perfect.
Velocemente, perché ho intuito, come succede sempre del resto, che c'è problemi di tempo.
As I said, we are running behind schedule. I know, I understand it. So this is briefly our research group. Professor Camazza, analytical chemist. We've got two students, Carlotta Di Bella and Martina. I cannot read the surname, I'm sorry, but the slide is very little. And there are two students, so PhD researcher, and of course Maria Grimaldi and Pittirollo. Grimaldi's PhD in chemist, and the second one received a research grant, and she won this grant from the also recognized by the European community, that the Parma lab is working and siding with University of Parma and GCAP. So basically it is a conjunction of activities working for the youngsters involved in research. These are the main topics. So analytical control, Professor Mochin expanded on. Markers of food products, process and storage. And then the study, development, and characterization of active, eco-sustainable, and eatable packaging. I'm sparing you the time dealing with analytical control. But I can say that the release of substances, for example, from some bottles of perfumes, is quite strong, because we remember the perfume, the scent is a quite powerful solvent. So, of course, we have release from the packaging directed to the product. It is, of course, a problem that we have to deal with. Then we can also go and develop brands of product, labels of product and process. So we specifically talk about markers and the soluble, for example, food fibers, as we said. So we can talk about the prebiotics, markers of thermal treatment, and linked to the thermal treatment, as I said. And then the shelf life assessment. So we have to check some parameters. Shelf life of packaging, as I said. Maybe we can study the technological data of some polycoupled product and see how these properties can change the shelf life of a specific product. Then, as a conjunction element, then Cavazza we'll expand on that. But 8 years ago, we started to study active packaging. Professor Volpi talked about intelligent packaging. Our packaging is active, interacting thereof, really interacting and constantly interacting with the food. So the packaging is interacting with the food element. So the example is here that we have is releasing lysozyme or natamycin, which acts getting in contact with the cheese. And so what happens is an active release that is progressive over time. So from this one, getting to eatable packaging, it's not automatic, because we have to move from polyethylene, PET, to materials that can be eco-sustainable and, in addition, edible, and in addition, active, so they can contain substances that are released over time, as we said before, or they can be eaten and then mixed with ingredients that are compatible or that are enriching the food itself. They can be directly eaten by those cooking the food. And then, of course, there's a primary packaging. So very, very briefly, because then I want to leave more time with my colleague, who will focus in depth on a specific element. And this was the main aspect about the master in packaging. And now I'm going to hand over to my colleague, Dr. Cavazza.
Salve, buongiorno a tutti, grazie
Good morning, everyone. Thank you for the warm introduction. So I am a part of the same research group. I know that we do not have much time. So we prepared some slides. How will the package be able to solve lots of food waste issue and try to avoid degradation, which was actually the main topic of Expo 2015. We know that there is a lot of, there are many wastes as for consumed products due to the huge supply chain. And the problem would be solved by using bio-eco-compatible and totally
possa essere risolto cercando materiali alternativi, quindi che abbiano meno impatto sull'ambiente. Come ci possiamo muovere? Quindi l'ideale sarebbe quello proprio di approcciarsi all'osservazione della natura, così come Leonardo, guardando il volo degli uccelli, ha progettato una macchina per volare e poi siamo arrivati alle nostre frecce tricolori. Allo stesso modo, se noi guardiamo un po' intorno, la natura ci offre degli esempi di packaging molto affascinanti. Quindi se pensiamo alle bucce dei mandarini, la buccia della banana, delle noci, ci danno un esempio di packaging che protegge il frutto internamente, sia da un punto di vista meccanico, quindi che aiuta dal punto di vista logistico, ma anche perché si tratta di packaging attivi, cioè packaging che contengono degli antiossidanti. Per cui il suggerimento potrebbe essere restituire all'alimento il suo vestito originario e far sì che siano queste stesse sostanze presenti nelle bucce della frutta, dei vegetali a proteggere il prodotto. Quindi economia circolare, reinserimento di scarti agroalimentari nel sistema produttivo, questa è quindi la sfida del packaging oggi. Sono tante le quantità di sottoprodotti che vengono scartate perché non sono adatti alla commercializzazione, quindi parliamo di frutta di dimensioni, di forma, di grado di maturazione non idoneo, oppure grosse quantità di scarti che vengono eliminati durante i processi tecnologici di produzione. Tutto questo potrebbe essere una nuova fonte quindi di sostanze utili. Quindi l'idea è quella di una rivoluzione nel packaging, quindi anziché far diventare il packaging un rifiuto, usare invece i rifiuti per generare packaging. Salto la parte, diciamo, relativa allo sviluppo di come siamo andati avanti quindi nei nostri laboratori con la preparazione di questi estratti, con la loro caratterizzazione dal punto di vista chimico, quindi analisi cromatografiche, spettrofotometriche e analisi di stabilità ossidativa dei prodotti, in maniera tale da verificare qual era poi l'azione effettiva di questi estratti inseriti nel packaging e così a contatto con gli alimenti e vado direttamente a qualche piccolo esempio di tipi di packaging attivo che abbiamo sviluppato. Una soluzione spray che può essere irrorata sui prodotti oppure dei film attivi che possono essere customizzati, quindi creati proprio ad hoc con caratteristiche di flessibilità, resistenza, spessore, caratteristiche nutrizionali specifiche per il tipo di prodotto che si vuole ottenere. Qualche studio di shelf life abbiamo provato a utilizzare questi dischi sugli hamburger e abbiamo ottenuto appunto una ottima stabilizzazione del colore, dell'odore, un controllo del flavor e un aumento della shelf life, così come lo spray sulla frutta che ci ha dato un controllo anche nello sviluppo delle muffe, quindi un ritardo nello sviluppo delle muffe. Questo può essere utile anche per funzionalizzare dei cartoni e renderli impermeabili ai grassi e quindi utilizzarli a contatto con alimenti per il takeaway, sempre nell'ottica di sostituire la plastica, perché appunto tutto questo rientra appunto nel discorso di produrre materiale che può essere biodegradabile o anche edibile. In ultimo, è importante far caso che però bisogna fare molta attenzione a tutti i materiali alternativi alle plastiche, perché non è detto che perché siano bio, diciamo provenienti dal mondo bio, debbano essere per forza sani. Ecco, purtroppo questo è uno dei lavori appena pubblicato nel 2020 che ci mette un po', ci pone un po' l'attenzione sul safe dei materiali alternativi alla plastica. Probabilmente ce ne saranno tanti altri. Uno degli esempi su cui abbiamo lavorato è il legno. Il legno viene accolto come un'alternativa alla plastica, ma in molti casi ha qualche problema sia dal punto di vista proprio della superficie che non è liscia, la possibile presenza di schegge, il fatto che il legno si deforma a contatto con l'acqua, perde quindi la sua forma, si rigonfia, può sviluppare muffe, quindi tutte cose che comunque ci rendono difficile accoglierlo come una soluzione a tutto. E con un coating che abbiamo messo a punto nei nostri laboratori siamo riusciti a eliminare un po' di questi problemi. Quindi il messaggio che è bene portare a casa oggi è quello che c'è ancora molto lavoro da fare in questo campo, sviluppare le conoscenze, e questo è possibile tramite informazione, tramite la formazione e il training. In questo ambito quindi vi presento questo master, il master che offre la nostra università, un master che c'è già da 10 anni e che riesce a fornire competenze in diversi ambiti, dall'ingegneria alla chimica, ai materiali, ma anche il design, la comunicazione, la legislazione. L'esperto in packaging è una figura professionale nuova che ha molteplici sbocchi, quindi in tanti campi, dal campo della ricerca ai macchinari, alla progettazione, allo sviluppo sostenibile. È possibile iscriversi anche per dipendenti aziendali per seguire dei corsi di aggiornamento professionale, quindi iscrivendosi solo ad alcuni corsi. Il nostro corso prevede lezioni frontali, queste saranno svolte online anche per via dei problemi che ci sono, problemi sanitari in questo ultimo periodo, e prevede comunque anche delle visite ai laboratori di ricerca, dei seminari per l'ingresso nel mondo del lavoro e dei corsi pratici. E vi lascio con la nostra pagina internet. Mi dispiace essere andata molto velocemente, ma purtroppo il tempo a disposizione era questo, quindi mi fermo qui con i nostri contatti e quindi siamo a disposizione quindi per darvi altre informazioni eventualmente.
Io ringrazio moltissimo la professoressa Cavazza e tutti coloro che sono intervenuti in questa giornata. Li invito fin da adesso ad usufruire insomma della nostra di info packaging della nostra rivista per degli articoli di approfondimento. Ci sono tantissime cose da dire, il vostro lavoro è estremamente importante e anche estremamente interessante, quindi sicuramente noi ritorneremo su questo argomento e proprio ritorneremo con degli articoli di approfondimento sulle vostre presentazioni di questa giornata. Vi invito in questo senso, dal momento che non abbiamo tempo secondo me di rispondere alle domande che nel frattempo sono arrivate, a scriverci a redazione@infopackaging.it, perché dedicheremo sicuramente più di un'uscita anche per soddisfare le domande di chi ci ha ascoltato durante questo convegno. Ringrazio l'Università di Parma, ringrazio il CIPAC, il professor Corradini e la professoressa Cavazza, tutti coloro con il professor Montanari e tutta la squadra del CIPAC che è intervenuta in precedenza, ovviamente Verona Fiera, e vi auguro buon proseguimento con questa prima edizione di Biopolymer. Grazie a tutti.